All right, today we're going to talk about the candidates test for absolute extrema and the AP problems that are accumulation and rates, and actually how these relate to each other. So there's not a lot of new information in this lesson. In fact, I'm not sure there's any new information, but we're just trying to take a look at information you already know from a new lens, so you know how it will be applied on the AP exam. So today we're going to do 3 practice AP exam problems. So when you learned about optimization in Unit 3, what you learned to do was to compare the y values at the critical points to the y values of the endpoints of a domain of a function to find the absolute min or absolute max of that function on the given domain. So we call this the candidates test because the candidates for the absolute min or absolute max are either the critical points of the function or the endpoints of the given domain. So there are 2 basic steps for finding an absolute max or absolute min. The first step is to identify the candidates. That means just list the critical points and list the endpoints if it's a closed interval. If it's an open interval, all you will have to do is list the critical points. And step 2 is evaluate the function at each of these candidates and then choose the max or the min. So let's take a look at just a basic example. F of x equals x squared minus 3. On the closed interval from -1 to 4, we're looking to find the absolute maximum value. So the very first thing that we need to do is to identify the candidates. Well, to do that, we first need our critical points. So f prime is taken by differentiating x squared minus 3, so f prime equals just 2x. And f prime equals 0, where x equals 0. So one of our candidates is the critical point where x equals 0. The other 2 critical points are the endpoints of the domain, which is where x equals -1 and x equals 4. And then we have to evaluate the function for each candidate. And I strongly recommend that you create a table of values. So you're going to have the critical point listed, and I'll put them in numerical order, -1, 0, and 4. And then you're going to evaluate the function at each critical point. So -1 plugging into f of x gives us 1 minus 3, or -2. Plugging in 0 to f of x gives us -3. And plugging in 4 gives us 13. Since our job was to find the absolute maximum value is 13. It happens to occur at x equals 4, but remember the absolute max or the absolute min is a y value. This table is your justification or support for finding your absolute maximum. So as the problems get more complex, this table of values will support your work and keep your work organized. So the other thing that we'll be talking about today is accumulation and rates. So these are very typical AP problems. You'll find one of them pretty much on every AP exam. And what they're doing is taking basically rate in and rate out. And you're going to use the fundamental theorem of calculus to find the total accumulation or change in an antiderivative function. So we're going to be starting to work with the FTC part 1, which we know to be big F of b minus big F of a equals the integral from a to b of f of x dx. And of course, that is where big F prime of x equals little f. So big F has a derivative of little f. By manipulating this equation, we come to a variation on the fundamental theorem of calculus part 1 that's very helpful with these problems. And effectively, I'm going to add big F of a to both sides of the equation. And that's what I get here. And if you think about it, big F of a is our starting point, or what we call the initial value. And if we take an initial value and we add to it the total change in big F, which is represented by the definite integral of little f, take the initial value, add to it the total change, you are going to get the ending value. So this piece here is the total change. So that just makes sense rationally, that you take a starting value, you add a total change, and you get an ending value. And of course, this holds only where the derivative of big F is little f. So this is called an initial value problem. And this puts into writing what I just said. You take an initial value, big F of a, you add to it the total change, and you obtain f of b, big F of b, the ending value. So an important part of working through the calculator intensive rates and accumulation problems is storing values on your calculator and using the stored values later in the calculations. So I strongly recommend that you bring out your TI-89 because we're going to be using it in these problems. So how are we relating the candidates test and accumulation and rates? Because I just reviewed two kind of concepts that you already knew, but I'm putting a new spin on them. So why do we bring them up together? Well, they're frequently tested together on the AP exam. So the most effective way to teach the blended concepts of the candidates test and accumulation and rates is to work through free response problems from past AP exams. And we're going to do 3 of those in these notes.